wanted to do this new series a little bit differently, in the sense that um, I think it will make more sense after I introduce like what the problem that KubeFleet is trying to solve, and then I will go into like what I'm trying to do with like this new series of community call. So thank you everyone for attending, and bear with me for a second. So in this meeting, I will first go through multi-cluster workload challenges. Um, and I assume that most people who are interested in a project like KubeFleet, or either in using it or developing it, are interested in solving some kind of a multi-cluster workload challenge. I will first explain what the challenge is, and then the second part of the meeting would be to explain how KubeFleet can help solve like multi-cluster workload challenges. And the third part of the meeting, after introducing what KubeFleet does, I will try to introduce a recently generally available feature called Stage Update Run, which allows people to place workload on multiple member clusters in a safe and progressive manner. And in the end, I will leave some time for open discussion. So first, I want to set the tone um, for for the for the discussion that we're going to having, which is to explain the problem. Multi-cluster workload challenges. So when I first heard of like multi-cluster, my first reaction was actually not that this is a hard problem, but my first reaction was why this was a hard problem, right? Because many people are doing like multi-cluster workloads. People might be using Argo CD to define um, their workload running in East US cluster, and then another copy of the workload running in West US. And maybe during a disaster recovery, they do a flip. They flip their workload from East US to West US and continue to run it in a different cluster, in a different region. It seems that a lot of people are already doing that, but why is it even a problem? So the more I learn about it, the more I can see that there's no a good solution for a multi-cluster workload challenges. The first one is what KubeFleet is solving, is workload management. Um, how do you choose the cluster that your workload wants to deploy in? So currently, most of the existing multi-cluster workload solutions, people manually choose the cluster or the region that you want to deploy to. You have to tell the tool that you want to deploy to West US, you have to deploy to East US, you want to deploy to West Europe or some APAC region. But that's not the thing that we want to achieve. I want people to be able to forget about um, clusters exist in so many different regions. The users shouldn't be manually choosing which cluster the workload goes to, but the tool should intelligently decide and figure out which is the best region for your workload to be placed in, and which is actually the goal of the KubeFleet project. And then the second challenge of multi-cluster workload is networking. Now that we want to place our workload intelligently to many different clusters, how we cannot set up the networking beforehand. We cannot set up a um, DNS a DNS record that points to our West Europe IP, because we don't know that our workload will be placed in West Europe yet before the workload management component makes the decision. So now networking becomes a uh, very important problem to be solved for multi-cluster workload to actually works. And the third challenge will be a state and data management. So once you go beyond like a very simple stateless application, you go into the space of having databases. Now you need to consider data replication, how it will work in a multi-cluster workload challenge. If KubeFleet or any workload management solution place a workload into a region that you didn't expect, or where your database is not available, it wouldn't work. You need to have data replication to that location. Otherwise, your application will be very slow. So the state and data management is another problem that is very important, and that's very challenging for any multi-cluster workload solution to consider. And of course, we have things like observability. You have workload running in many, many different clusters. How would you be able to consolidate your log and view the logs and the status and monitor the status of your workload in a single place across like many different clusters? And then we have security, which includes like how to replace secrets, deliver secrets securely to um, different clusters, and how do we make sure that the components or your different clusters workload on your different clusters can communicate with each other securely. All of those are very interesting topic. Now, I want to go back to what I mentioned originally about what I want to do a little differently for this series is that apart from introducing KubeFleet, I also want to explore how the KubeFleet solution, which is focusing on the workload management perspective of the multi-cluster workload challenge, how it can be used together with other solutions out there that handles networking, that handles state and data management. And I actually don't have a good solution yet because I haven't tried it, and but I want to try it as like a real user of a multi-cluster workload solution would do, which is they want the whole package. They have to set up everything, and I want to try that. Um, okay, next slide. What is KubeFleet? So as I have already mentioned in the last slide, KubeFleet is a solution that's trying to solve Kubernetes multi-cluster workload management. It's an open source project. It's a CNCF sandbox project, and our team donated this project to CNCF about a year ago, and right now it has like 146 GitHub stars, um, dozens of contributors, and and what it tries to do is that it tries to provide a unified um, API that allows users to place resources across clusters with smart scheduling. And we are also recently adding a new feature that allows people to roll out challenges progressively and safely, which is something that I'm going to demo soon. Now I want to give like a quick overview of the key features of KubeFleet. Firstly, on the left-hand side, we have multi-cluster orchestration. So in KubeFleet, we have a hub cluster. That's basically your control plane cluster. You do all as a cluster administrator, you do all of your cluster admin work on the hub cluster. You create resources on the hub cluster, and then the KubeFleet tool is responsible for propagating the changes to member clusters. And um, and now that we are talking about propagating changes to member clusters, KubeFleet also offers intelligent placement, which means that you don't have to specify exactly which cluster your workload should go to, but based on certain constraints that you predefine and capability of that are offered at each member clusters, KubeFleet is going to choose the most appropriate clusters to place your workload in. And the third point, progressive rollouts. In the beginning, KubeFleet was only able to do rolling updates, which is mirroring what a typical Kubernetes deployment does. It in the rolling update, you roll out to one cluster, and if it's healthy, you the tool immediately kicks off another rollout to the second cluster. And there's no way for you to say, I want to wait. I want to bake the change in the first cluster for 24 hours before I move on to the next. And there's also no way for you to say, I want to approve the change before it goes out to production. And so we have a new feature that fixes this. And lastly, we have drift detection and overrides. So in some cases, this is to address like some more advanced use case where a user doesn't really want to override a workload in all the member clusters right away. They want to see if the existing workload on the member clusters are any different from the desired state that we define in the hub. And then this can be used for troubleshooting, and if you do a drift detection first, maybe it can avoid production outage if to so that you can investigate whether it's safe to roll out your changes to all of your member clusters first. And then hub and spoke architecture. So let me go into the KubeFleet architecture for a little bit. So the summary of it is that it's a hub and spoke architecture where we have a hub, Kubernetes cluster as a control plane. And then we have an agent running on the hub that it's responsible for scheduling work to all the member clusters. And then in each member cluster, we also have an agent running there, and that's the member agent is responsible for executing the work that are scheduled by the hub cluster. Okay, now I have spent some time talking, and I want to do like a demo on this feature that I mentioned quite a few times by now, which is stage update run demonstration. So just as a quick recap, this feature is about progressively rolling out your changes to all of your member clusters and allowing you to define either wait or approval before your change move on to the next stage. Even though I have prepared some video, but I'm going to do this live, and the video is just for a fallback. Hey, sorry about the Teams message. Okay, I'm going to follow this quick start that I wrote yesterday with the help of AI. So in this end-to-end demo, what I'm going to start with creating kind clusters. So kind cluster is is a a very lightweight way to run Kubernetes cluster just as containers on your VM. And I'm going to create 3 clusters. We're going to have the hub cluster and 2 member clusters. And the hub cluster, as I just mentioned, it's the control plane of a KubeFleet. And the member clusters, they are the Kubernetes clusters that actually runs the workload. And then after creating the clusters, I will install the necessary KubeFleet infrastructure, which means the hub agent on the hub cluster and member agents on the member cluster. And then after that, I would use a Kubernetes Headlamp plugin to show you like how the different resources, KubeFleet specific resources that I'm going to create and manage in this demo, and also I'm going to deploy a demo application, which is a banking configuration application that has like a Python backend and a JavaScript frontend, and I'm going to deploy that using KubeFleet to our 2 member clusters. And our first member cluster will be used as a staging cluster, and our second member cluster will be used as a production cluster. And in the demonstration, I will set up the KubeFleet rollout such that it deploys to the staging cluster first, and then there will be a 1 minute wait and an approval before you can actually roll out to the production cluster. And then I will also show like how we can make a request or how we can see the application running in staging and production. Okay, now let's get started. First step, I will create the kind clusters, which are the hub, the members. As you can see on the screen, it will take maybe 1-2 minutes to finish the entire hub and member cluster setup. Yeah, and the reason that I want to do this like from scratch is also that I want to show people how like you can do this like from scratch. And if any audience want to try this, try a quick start, I will probably give everybody a link later. You can do like very similar things to try out KubeFleet very quickly on your Linux VM or on your Mac desktop. Okay. Now we're just waiting for the member cluster to get set up. Okay. Now the kind clusters are set up. The next step is installing a hub agent to the hub cluster. So one thing to note is that the official way of installing hub agent in KubeFleet is to use Helm. So we might support different ways of installing hub agent in the future, but right now Helm is the way to do it. And it's pretty quick. Now let's just validate that the hub agent is running fine on the hub cluster. As you can see, it's running. So that's very good. Let's move on. Now the next step is just grabbing the IP of the hub cluster because we need this because the member agents will need to talk to the hub cluster and they need to know the hub IP. Okay. Now next step is installing the member agents on the two members and join them to the hub cluster. Joining is like a KubeFleet jargon. It basically means that make hub cluster aware of the member clusters and make them establish communication with each other so that workload placement actually works. Now let's run that. And I'm not going to do the clone step because I have already cloned it on my computer. Next step, after installing, the member cluster might take a little while to come up. I think it's already working, so which is very good. And another just a diagnostic step is to just look at the member cluster CR custom resources created in the hub. This is the way that the hub cluster can keep track of which are the members that it is managing. As you can see, there are two member clusters, member 1 and member 2, and they are in the join state, which means that the member agent and hub agent, they can communicate with each other perfectly. And yeah, they just join. So, and next step, I'm going to label our two member clusters as staging and production. Right, this is for the later demonstration where I will be deploying the workload to staging first and then wait a little bit. And then I will need to approve so that the workload can go to prod. Okay, this step, we have a little nice Headlamp plugin that one of the team members did a few weeks ago. And with this Headlamp plugin, we can actually visualize the entire um, KubeFleet management process. And I'm going to run this, the Headlamp UI. Actually, I need to go to a different Headlamp UI in a container. Now, after this, we can actually go to the UI on port 8080 and then see what we have just done. So wait. So just to recap, we have just set up 3 kind clusters, like a hub, 2 members. The members are member 0 and member 01 and member 02. And then most of our activities will happen in the hub cluster. And then this is our little KubeFleet Manager plugin. And we can see that we join 2 member clusters to the hub. And now I will move on to the actual workload placement feature using this UI. Okay, but first I need to build my sample app. Sample app is just a simple configuration service that stores a dictionary of configuration. You have your configuration key, your configuration value, and then you can edit the configuration on the web UI. But at this point, we do not have any data like persistent scalability because I have not set up the multi-cluster data management part of the demonstration yet, and also have no networking. So as the first demonstration in the series, I'm going to demonstrate like bare minimum workload management capability, and I will explore more in the subsequent meetings. So what I just did was I built the application and push that to GHCR, and this is just my GitHub account. And now the next step, I would need to apply the sample application to the hub cluster. And then set the container image version to the version that I just built and push. And we will need to look at the deployment that's actually on the hub cluster. And I think first time KubeFleet user might be baffled by this, what you are seeing here, where like the backend and the front end, they are not ready on the hub cluster. This is actually by design. So by design, the hub is just a control plane. It's not a data plane thing. So we don't intend it to be running any workload. That's why we have validation webhook that stops replica set and pop and pod from spinning up in hub. That's why you see that they are not ready. That's because our validating webhook, it's stopping you from doing that. But we do have a way for you to configure it such that you can run workload on your hub as well. That's actually a use case that people talk about, where people need to run compliance agents, security agents in their hub, especially for industries which are heavily regulated. Okay. Next step. Now this is a very KubeFleet specific thing. It's called a cluster resource placement. So what this custom resource is saying is that I want to propagate my namespace, name KubeFleet sample, which is where my sample application is deployed to. And I want to deploy that to all of my member clusters that are joined to the hub. And the strategy external here means that we are not going to use the built-in rolling update functionality, but we are going to use another mechanism called stage update run, which allows you to roll out your application progressively and safely. Now let's take this YAML and like that. Apply. And then apply sample CRP. And it's going to show up here. Now, after defining the placement strategy, which is I want to deploy my sample app in this namespace to all of my member clusters using external rollout strategy. Now, next step is to define the actual update strategy. So in this strategy, we have two stages, a staging environment and a production environment. And if you still remember, I label the member cluster 1 as environment staging, and I label member cluster 2 as environment production. And this strategy references that label and say that we deploy to the staging environment first. And after deploying to staging environment, we need to wait 1 minute. This is to simulate like a baking period after you deploy your applications to staging. And then we move on to the production deployment. But before we start the production deployment, we would need an approval from a human. And I will demonstrate how we do the approval as well. But now, for now, let's apply the strategy. Okay, now that it is applied, now we have a strategy that defines what are the stages, and we have a resource placement, which defines like which member clusters I'm going to pick. Now the last step would be to start a run, actually trigger the deployment. Going to apply by selecting the strategy and the placement. And right now, because I have to make this bigger so that it's clear. And after having the run, you will need to start it. And now we are just waiting a little bit for this rollout to complete in the staging environment. Now you can see that it actually completed because it moved on to the waiting stage. The waiting is configured after the staging deployment was done, and we are waiting for 1 minute before we can move on to production. And now we can also validate that the application is running in member 1. So we are port forwarding the service from member 01 to a local port so we can actually see the application running. And then we've port forwarded to 8081. And you can see that this is running like a mock application. Like all these data, they are stored in memory yet for now. And I'm planning to explore how to make them persistent later. Okay. And this is our staging environment, which is up and running. Now, after some waiting, now you see now we are at the stage where the waiting is completed. Now we are waiting for the approval because 1 minute has passed. So you have to approve it. You don't have to leave any message. And after approving it, it will get deployed to production. And under the hood, the approving mechanism is actually patching the a custom resource called cluster approve request, and you set the approve state to true. But it's easier to do this on the UI. Okay, now the deployment is complete. We can check production application as well by forwarding the service running on member 2 onto local port 8082, which is this. And then I'm going to refresh. It should work. It should actually be reading. Yep, and this is our production environment. And that basically concludes the demo. There's some part where like we can make some update and then we redeploy, but maybe I guess I will probably post the, the instruction in the chat and then people can try it later. And okay, let me go back to the slides. Okay, now we are in the last section of this presentation, which is we have our website. It has like fairly detailed um, instruction on how to set up KubeFleet and try it yourself. And then if you are a contributor that wants to that just starting out, you can look at our good first issues list and try to address some of the issues. And this is our GitHub repo. And then if you are interested in further community call schedules, you can pay attention to this community calls link. And thank you everyone for listening. And now I'm going to end the presentation and we can do discussion if everyone is interested. But first of all, if anyone have any questions on any of the presentation, you can leave a message in chat and you can also reach out to us on our GitHub and discuss the issue with us. Thank you very much. Okay, that's it.
Yeah, I added a few questions. Did we stop the recording?
Um,
I added a few questions for clarification, but if you want to talk about them for
yeah,
like a
definitely.
minute for each,
Yeah. I think I don't need to stop the recording. I should
Oh, no,
just
no, no. Yeah.
respond to questions maybe. Let's see. Even if we want to run workloads on the hub, can we do it easily? Can we have a stage run, have hub as one of the stages to do a deployment to? Oh, it's not a feature that's supported yet. Um, so I think the reason is that right now we can only have one hub. So you always like do deployment to one hub. Like it's not possible to skip deployment to even one hub, right? You have to first define your resources somewhere and then like there's no way you can skip that work. But of course, if you are talking about deploying to 50 member clusters, you want to do the same work. You don't want to define the same thing to 50 different clusters, and that's the problem that we're trying to solve. But we are not automating um, how to deploy to the hub. But um, and our recommendation right now, our recommendation of doing that is that maybe we can set up some Argo CD pipeline that automatically syncs your GitHub repo or your any Git repo to a hub. And that's the way that we think it's best. It- That's I think it's the best way to deploy our workload to hub as of today. But of course, if you think that there's a better way, we can always like have discussion and create issue. in KubeFleet. Second question, can we talk a little bit about cluster resource placement and resource placement for clarity? Yeah, definitely. So just now in the demonstration, um, I think I should share screen again so that I can use like the nice little headlamp UI to show you what I mean by cluster resource placement. So in the little headlamp UI, we have a tab just for resource placement. So resource placement is concept that has two particular instances. One is cluster resource placement, which is the one that I just demonstrated. A cluster resource placement primary use case is to deploy an entire namespace from hub to member cluster wholesale. The assumption is that usually one Kubernetes application is being packaged into a namespace, and that's considered a best practice in Kubernetes. Um, but we do realize that there is some limitation to what a cluster resource placement can do, which is that sometimes multiple teams and multiple deployment schedule might happen within the same Kubernetes namespace. For example, a platform team might want to enforce some network policy or enforce some resource quota on your namespace, and they want to deploy those resources to an application namespace at a different schedule. That's different from what the application team might follow that deploys their application to the namespace. So later we added an additional type of resource placement, just called resource placement, and it is a namespace scope custom resource, and we use this custom resource to allow fine-grained selection of namespace scope resources within your namespace without needing to deploy the entire namespace to your member clusters. So going back to the specific example that I just talked about, um, the platform team can deploy the namespace and with some resource quota and network policy to some member clusters, and the application team can use a namespace scope resource placement to select the specific deployment, service, config map, and secret from the hub and deploy them to member clusters. Okay, let's zoom. One more question. Oh, the zoom. Wait, where is the chat? Where's the chat? One more question. There is a cluster stage update strategy, and is there a stage update strategy? Yes, that's a really good question, and that's really relevant to what I just talked about, which is the last question. Is the difference cluster scope versus namespace scope resources? Yes, that's exactly it. So the question is, just now I show you how to define a cluster stage update strategy, which is a strategy that's very specific to cluster resource placement. And we have another variant of this called a stage update strategy, and that's namespace scope, and that's specific to resource placement. And the only difference between them is one is cluster scope, one is namespace scope. And they have very similar, if not identical features. You can um, define stages, and you can define tasks between stages. By tasks, it's just either wait after a stage or before a stage, you need some approval. And that's it. That's all the question for now. And thanks, Yakin, for the